It's located at negative 3, 1. Here's another point. Negative 1, negative 1. Now we're ready to start step 1. We're going to use the equation in vertex form to substitute the observed values. We have our vertex, h and k, which is negative 3, 1. And we have our x and y values that are going to come from our other point, negative 1, negative 1. So we substitute them in. Our h of negative 3 goes here. Our k of 1 goes here. Our x of negative 1 goes here. And our y of negative 1 goes here. Now, we'll move on to step 2, which is to isolate for the unknown a. So negative 1 is equal to a times negative 1 plus 3 squared plus 1. We'll solve what's in the brackets first. Negative 1 plus 3 is 2. So negative 1 is equal to a times 2 squared plus 1. So negative 1 is equal to 4a plus 1. Negative 1 minus 1, so we've gotten rid of the 1 on this side, so it becomes a negative 1 on this side. So negative 1 minus 1 is negative 2. Negative 2 is equal to 4a, and so a is equal to negative 2 over 4, or a is equal to negative 1/2. Now this seems to make sense. It's negative, therefore it's facing down, as we can see here. So the negative makes sense. This is a half, which is smaller than 1, which will make the parabola look like it's a wider u. And this does look like it is a wider u than y equals x squared. So this a value seems to make sense. Our third step is to rewrite the equation substituting a, h, and k. Here's our vertex form, our value for a, h, and k. We'll substitute them in. A is negative 1/2. Here it is. H is negative 3. Here it is. And k is 1. And there you are. So the equation is y equals negative 1/2 times x plus 3 squared plus 1. Determining the equation of a quadratic from its graph, from the factored form. In this activity, we will explore how to determine the equation of a parabola in the factored form, y equals a times x minus r times x minus s, from its graph when the scale allows you to read the coordinates of the zeros and at least one other point, x and y. To write an equation in the factored form, we need the values of a, r, and s. A, r, and s. If the coordinates of the zeros, r, 0, and s, 0, can be determined by looking at the graph, then the stretch factor a can be calculated provided that we can read the coordinates of one more point, x and y, on the graph other than zeros. To determine the equation of a parabola, given the coordinates of the zeros and one other point, x, y, follow these steps. Here's our parabola. We're going to determine the equation of this parabola. The first thing we need is to identify the zeros. These are the two zeros. And we need another point. We've identified this as our other point. Step 1. Use the equation in factored form to substitute the observed values. Here is our factored form. First, what we need is our r0. Our coordinate r0. This corresponds to the first 0, or first x-intercept. It's at -3, 0. The other 0, or x-intercept, will provide our s value. The coordinates for the other x-intercept is -1, 0. So now we have our r, and our s. Our x and y comes from the extra point that we've located here. The x and y coordinates for that point are -4, -6. We now substitute in these values into this equation. Our y is here, -6. Our a we don't know. Our x is -4. Here it is. And that goes in two places. Here's another x, which goes here. And we have our r, which is our -3, and our s, our -1. Step 2. We're going to calculate the unknown value, a, by solving for the equation for a. So, -6 equals a times, in brackets, -4 plus 3, times, in brackets, -4 plus 1. This is equal to -6 equals a times -1 times -3. So -6 is equal to 3a. Therefore, -6 divided by 3 is equal to a, or a is equal to -2. Does this a value make sense? Well, it's negative, which means the graph or the parabola should open downward, which it does. And the 2 means that it is slightly stretched. And it does seem as though it's stretched if you were to compare it to the y equals x squared parabola. Step 3. We'll now rewrite the equation, substituting r, s, and a. Here is the factored form of a quadratic relationship. A, we just found out, is -2. R is -3, and s is -1. Therefore, y is equal to -2 times, in brackets, x minus -3 times, in brackets, x minus -1. Therefore, the equation is simplified into y equals -2 times, in brackets, x plus 3 times x plus 1, in brackets. Determining the equation of a quadratic from its graph in the standard form. In this activity, we will explore how to determine the equation of a parabola in the standard form y equals ax squared plus bx plus c from its graph when the scale allows you to read the coordinates of the y-intercept, 0, c, and at least two other points, x1, y1, and x2, y2. To write an equation in the standard form, we need the values of a, b, and c. If the coordinates of the y-intercept 0, c can be determined by looking at the graph, then the two missing values, a and b, can be calculated provided that we can read the coordinates of two more points, x1 and y1 and x2, y2, on the graph other than the y-intercept. To determine the equation of a parabola given the coordinates of the y-intercept, 0, c, and two other points, x1, y1, and x2, y2, we'll follow these steps. Here is our parabola that we are going to determine the equation in standard form. We're going to look for 2 points. Here is our first point. Here is our y-intercept. And we'll need another point. This is our x1, y1. This is our x2, y2. And this is our y-intercept. Step 1. We'll use the equation in standard form to substitute the observed y-intercept and one of the points. Our y-intercept, 0, c, is here, 0, -2. It's at -2 on the y-axis. Our x1 and y1 are -4 and 6. That's this point, -4 and 6. So we'll substitute these values in. Our y is 6 from here. Our a we don't know yet, but we know our x, which will be our x1, which is -4. Our b we don't know yet, but we do have, pardon. Our b we don't know yet, but we do have our x, which is -4 again, plus -2, which is our c, or y-intercept. This simplifies to 6 equals 16a minus 4b minus 2. Step 2. We'll use the equation in standard form to substitute the observed y-intercept and the other point. 0, c, which is 0, -2 again. And we'll now use our x2 and y2, which is 6, 1. That's this point. So we'll substitute these values in. Our y is 1. Our a we don't know, but our x value is 6, goes here, plus b times x, again our 6 goes here, plus c, which is our -2. This simplifies to 1 equals 36a plus 6b minus 2. Step 3. We're going to solve the system of equations with the method of your choice, by graphing, by substitution, or by elimination. Here we will solve it by elimination. So we have our first one, our first equation using x1, y1. That was 6 equals 16a minus 4b minus 2. Our second equation was 1 equals 36a plus 6b minus 2. This was using the y-intercept and x2, y2, the coordinates of our second point. We're going to multiply this top one by 3 and this bottom one by 2. So the top one becomes 18 equals 48a minus 12b minus 6. We can do this because whatever we did to the right-hand side, we did to the left-hand side. So we haven't changed anything. We'll do the same with the bottom, except multiply it by 2. We multiply the left side by 2, which is equal to 2. And on the right side, we have 72a plus 12b minus 4. Now what we're going to do is add. (18) plus 2 is 20. 48 plus 72a is 120a. Negative 12b plus 12b is equal to 0. And negative 6 plus negative 4 is negative 10. So what we did here is we wanted to eliminate the b unknown so that we can isolate a. So 20 is equal to 120a minus 10. Or 30 equals 120a. So a is equal to 30 over 120, or a is equal to 1/4. Going back to the first one, 6 equals 16a minus 4b minus 2. We'll now substitute in the a value. 6 equals 16 times 1/4 minus 4b minus 2. Now what we'll do is we'll isolate the b and find out what our b value will be. So we have 6 equals 4, because 16 times 1/4 is 4, minus 4b minus 2. So we have 6 equals 2 minus 4b, or 4 equals negative 4b. b, then, is equal to negative 1. Step 4. We're going to rewrite the equation substituting a, b, and c. Y equals ax squared plus bx plus c. This is the standard form for a quadratic relation. Our a is 1/4, our b is our negative 1, and our c is negative 2. So our standard form for the quadratic relation is written y equals 1/4 x squared plus negative 1 x plus negative 2. This is simplified to y equals 1/4 x squared minus x minus 2. As you can see, the first two forms of the equation were much easier to obtain. To obtain the standard form from a graph, it involves more steps and it's a bit more complicated.